So here we have an orange and here we have a peeled orange. Do you think that they will float in water? Let's see. First we will try the normal orange. We can clearly see that it floats. Now we will try the peeled orange. It doesn't float. Let's see why.
In this experiment, we're exploring the concepts of buoyancy. First thing first, in order to understand this, we have to know that in a situation of fluid statics, the net upward buoyancy force is equal to the magnitude of the weight of fluid displaced by the object. The center of buoyancy is the centroid of the volume displaced. Next, we shall see what we're talking about in terms of formulas. The formula for buoyancy force is the vector that comes from the product of the density of the fluid times the gravity and the volume displaced by the object in the liquid. The pressure downwards of the object is larger than the pressure upwards, therefore it generates buoyancy force upwards, this being the reason why things float.
Since the buoyant force is forces, we're going to do a free body diagram and analyze two cases. The first case, we're going to analyze a free body diagram where we have the buoyancy going upwards and the weight going downwards. That means that the sum of forces is going to be equal to the buoyancy minus the weight equal to 0. Then by substituting buoyancy with the density of the liquid times the volume displaced times gravity is going to be equal to the weight, but we're going to substitute m by the volume times the density of the object and times the gravity. Then we can cancel out gravity and the volumes to only have that the density of the liquid is going to be equal to the density of the object. This case is given when objects just float in the, don't go upwards, no downwards, but they are submerged in the liquid. Our second case is going to be the same free body diagram, but the sum of forces is going to be equal to mass times acceleration. And we can cancel out again the volumes and the gravity to only have that if buoyancy is larger than the mass times the gravity, the weight, then acceleration is going to go upwards. But if the buoyancy is lower than the weight, then acceleration is going to be downwards. That is why our oranges, we can see that when it's not peeled, it's going to go downwards, and when it has the peel, it's going to go upwards. Now, why does this happen?
Going back to our experiment that Karen showed you, turn it around please. The difference in buoyancy comes from the peel. As Pachi explained to you, when there's different densities, something floats when it's less dense than the other thing. The denser thing here, or fluid, is the water. When we have a peel in the orange, we can actually have some air caps that fill inside the orange. When we have air inside, it makes it float because there's a difference in densities, and thus there's a greater buoyancy force making it go up, and it's less dense, so it floats.
So, in conclusion, we can see why buoyancy, while being very simple, is very important. We have buoyancy in everything. We have buoyancy in boats, we have buoyancy in planes, and in simple objects like oranges.